This is SpaceTime Series 25, Episode 138. Coming up on SpaceTime, the first ever sound recording of dust devils on Mars, what the first galaxies were and weren't like, and Chinese Taikonauts return home following a successful Shenzhou 14 mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have heard the first ever audio recording of dust devils twisting their way across the surface of the red planet Mars. It's the first time one of these extraterrestrial whirlwinds has been heard on another world. When the Mars Perseverance rover landed on the red planet back in February last year, it was equipped with the first working microphone ever to visit the red planet's surface. NASA's Mars Polar Lander mission back in 1999 also included a microphone, but that spacecraft crashed on arrival after mission managers and builders got their imperial and metric measuring systems mixed up. So the sounds coming from Perseverance's microphone represent the first audio we're hearing from the surface of another world. The study's lead author, Perseverance Supercam principal investigator Roger Wiens from Purdue University, says scientists can sometimes learn more simply by listening to the sounds they hear compared to what they can from other tools. You see, the microphone takes readings at regular intervals, and it lets scientists sample nearly 100,000 times a second. And that helps them get a stronger sense, a stronger feeling, one might say, for what Mars is really like. The microphone isn't on continuously. It records for about 3 minutes every couple of days. Wiens says just like Earth, there's different weather in different areas of Mars, and using all of Perseverance's instruments and tools, especially the microphone, helps to get a concrete sense of what it really would be like to be on Mars. Getting the whirlwind recording was lucky, though not necessarily unexpected. In Jezero Crater, where Perseverance landed in February 2021, mission managers had observed evidence of nearly 100 dust devils, tiny tornadoes of dust and grit. But this was the first time the microphone was on when one of these dust devils passed over the rover. The sound recording of the dust devil, taken together with air pressure readings and time-lapse photography, helps scientists understand the Martian atmosphere and weather. Wiens says he could literally watch the pressure drop, listen to the wind, and then have a slight bit of silence. That's when the eye of the tiny storm passed over the rover, then hear the wind again and watch the pressure rise. And it all happened in just a few seconds. That's because the wind was moving fast, about 40 kilometers per hour, which is roughly the same speed dust devils on Earth travel at. Of course, the difference is air pressure on Mars is so much lower than on Earth. So the winds, while just as fast, push with only about 1% the pressure at the same speed of winds back on Earth. The data recorded by the car-sized six-wheeled Perseverance rover and reported in the journal Nature Communications shows that it's not a powerful wind, but clearly enough to loft particles of grit and dust high into the air, forming a dust devil. The information confirms that future astronauts won't have to worry about gale force-sized winds blowing down antennas or habitats, so future Mark Watneys won't be left behind. The breezes were known to blow grit off the solar panels on some of the rovers, especially Opportunity and Spirit, which may have helped them last much longer. Rover teams would see a slow decline in power over a number of days to weeks, then a sudden jump. That was when the winds cleaned off the solar panels. Of course, eventually, dust on the solar panels got so bad wind wasn't enough, bringing the Spirit and Opportunity missions to a close. This is SpaceTime. Still to come, a new study looking at what the first galaxies in the universe were like, and Chinese Taikonauts return home following a successful Shenzhou 14 mission. All that and more still to come on SpaceTime. Astronomers have been able to make some key determinations about the universe's very first galaxies, an epoch known as the Cosmic Dawn. Using data from India's Saras 3 radio telescope, researchers were able to look at the very early universe, just 200 million years after the Big Bang. And in the process, they were able to place limits on the mass and energy output of the first stars and galaxies. Counterintuitively, the authors were able to place these limits on the earliest galaxies by not finding the signal they had been looking for, known as the 21 centimetre hydrogen line. This non-detection allowed the researchers to make other determinations about the cosmic dawn, placing constraints on the first galaxies, enabling them to rule out scenarios including galaxies which were inefficient heaters of cosmic gas and efficient producers of radio emissions. The results, reported in the journal Nature Astronomy, represent an important transition in understanding how our universe transitioned from mostly empty to one full of stars. Understanding the early universe, when the first stars and galaxies formed, is one of the major goals of all new observatories. The Square Kilometre Array project, now being built across outback Western Australia and Southern Africa, will likely be able to make images of this early universe. But for current telescopes, the challenge is to detect the cosmological signal of the first stars, re-radiated by thick hydrogen clouds. The signal is known as the 21 centimetre line. It's a radio signal produced by hydrogen atoms in the early universe. Unlike the James Webb Space Telescope, which is able to directly image individual galaxies in the early universe, studies of the 21 centimetre line made with radio telescopes can tell astronomers about entire populations of even earlier galaxies. To detect the 21 centimetre line, astronomers look for radio signals produced by hydrogen atoms in the early universe affected by ultraviolet light from the very first stars. In 2018, another research group operating the EDGES experiment published a series of results which hinted at a possible detection of this earliest light. The reported signal was unusually strong compared to what was expected in the simplest astrophysical picture of the early universe. Recently, the SARAS-3 data disputed this detection, and the EDGES result is still awaiting confirmation from independent observations. In a reanalysis of the SARAS-3 data, the authors tested a variety of astrophysical scenarios which could potentially explain the EDGES result, but they couldn't find a corresponding signal. Instead, they were able to place some limits on properties of the first stars and galaxies. The results of the SARAS-3 analysis is the first time that radio observations of the average 21 centimetre line have been able to provide an insight into the properties of the very first galaxies to form. The authors were using the data from the SARAS-3 experiment to look for signals from cosmic dawn, when the first galaxies formed. The study's lead author, Harry Bevins from Cambridge University, says his team were looking for a signal with a specific amplitude, but by not finding that signal, they could place limits on its depth. And that in turn begins to inform astronomers about how bright the first galaxies were. The analysis shows that the hydrogen signal can inform scientists about the population of first stars and galaxies by placing limits on some of the key properties of these first sources of light, including the masses of the earliest galaxies and the efficiency with which these galaxies formed stars. The study is the first of its kind in many respects. It excludes scenarios in which the earliest galaxies were both more than 1,000 times as bright as present-day galaxies in their radio band emissions, but were still poor heaters of hydrogen gas. And the data also reveals something which had been hinted about before, namely that the first stars and galaxies could have made a measurable contribution to the background radiation that appeared as a result of the Big Bang, and which has been travelling towards us ever since, by establishing a limit to that contribution. This is SpaceTime. Still to come, Taikonauts aboard the Shenzhou 14 capsule have returned safely to Earth. And later in the science report, a successful test for a new American prototype hypersonic missile. All that and more coming up on SpaceTime. Taikonauts aboard the Shenzhou 14 spacecraft have returned safely to Earth following their 6-month stay aboard China's new space station. Their charred and blackened capsule touched down under parachutes on the Dongfeng landing site in northern China's Inner Mongolia 71 minutes after undocking from the orbital and service modules. It's the first time a Chinese manned spacecraft has landed on the Dongfeng site under winter night conditions. The Shenzhou 14 and its 3-person crew had launched towards the Tiangong or Heavenly Palace space station back on June the 5th. While on station, the crew oversaw 5 rendezvous and dockings performed by the spacecraft. They undertook 3 extravehicular activities or spacewalks to attach new equipment and antennas to their orbiting outpost. They gave a live science lecture, conducted several experiments, and installed new equipment sent up to the space station. They also saw the world's fastest automated rendezvous and docking of a supply ship. That was the Tianju-5, which docked to the space station in just under 2 hours. And the trio also conducted China's first in-orbit crew rotation, handing over to the new incoming Shenzhou 15 Taikonauts. The Taikonauts from Shenzhou 15 are now tasked with the job of wrapping up the first stage of space station construction, integrating the remaining components of the station which are yet to be attached, and kicking off the first stage of space station operations. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.